Yann LeCun just left Meta, raised $1 billion, and is betting his entire future on a radical idea that large language models alone will never achieve human-level intelligence. His alternative, a system called JEPA, but is it the real deal or just another magic bullet? So here is the core question that Yann LeCun has been wrestling with for years. He is a Turing Award winner, one of the founding figures of modern artificial intelligence, and he pioneered the convolutional neural networks that underpin everything from smartphone image recognition to autonomous driving. He left Meta after more than a decade as chief AI scientist, and he did it because he believes the industry is heading down the wrong path. His argument, as he put it in a Nebius Science interview, is that LLMs can answer questions and generate text, but they do not literally understand the physics of the physical world. Being able to explain a task and actually performing it are two completely different things. An LLM can describe how to open a bottle, but it has no model of gravity, momentum, or the spatial relationship between its gripper and the object. That is the gap LeCun wants to fill. After leaving Meta, LeCun moved to Paris and founded AMI Labs, which stands for Advanced Machine Intelligence. The lab is tucked away in the Sentier district between a perfume shop and a fashion boutique. It is backed by $1 billion in investment from Nebius, and LeCun is using that capital to pursue what he calls AI for the real world. His whiteboards are covered in sketches of predictive architectures, contrastive loss functions, and vector diagrams showing how a machine should represent states like bottle open and bottle closed. The idea is that a machine needs to foresee the consequences of physical events, like when a bottle is about to tip over and spill, or when a robot arm needs to grasp something it has never seen before. JEPA stands for Joint Embedding Predictive Architecture, and it is fundamentally different from the generative approaches that dominate the field. Instead of predicting individual pixels or tokens, JEPA works in a latent space. It uses self-supervised learning to build a model of the world that predicts how high-level states will change when actions are taken. The contrastive loss function guides the system guesses toward correct answers by pulling similar states together and pushing different states apart. LeCun describes it as a predictive architecture that learns the structure of behavior rather than the surface of how things look. This is what he believes is the path to machines that can plan, reason, and act in the physical world. Here is the thing that makes LeCun's position so provocative. Today, he is essentially arguing against nearly the entire field of artificial intelligence. The industry continues to hit milestone after milestone using large language models, and those models are getting better every day. LeCun's view is that those milestones, while impressive, will not on their own lead to human-level intelligence. He has been a contrarian for a long time. He believed in self-supervised learning when labeled data was king, and he pioneered convolutional networks when the field was skeptical. Now he is saying the same thing about LLMs. He told Nebius that world models are this season's hottest trend and that everybody claims they are doing it, but nobody knows what it actually is. AMI Labs is working on several concrete applications of world models. One example is medical treatment planning. If you have a patient with a chronic disease like diabetes, a world model could predict what course of treatment should follow to keep blood sugar under control over time. Another application is robotics. LeCun envisions robots that can handle new and complex tasks on their first try without needing millions of training demonstrations. The system would learn the laws of motion, the relationships of conservation, and the causal structure of the physical world. This is what separates JEPA from simply generating realistic videos. It is about understanding the underlying structure that governs how things behave. The Reddit community on the machine learning subreddit had some interesting reactions. One commenter named Cosmolithe pointed out that JEPA has the right goals, like making planning easier and more efficient, but is not the right solution. Another commenter, 314 Cabinet, described LeJEPA as a neat and elegant architecture, but noted that JEPA itself does not really address partial observability in a thorough manner. A user named Moshels raised a serious point. JEPA is still a form of traditional learning with no directed response to address adaptation at deploy time, meaning it will fail catastrophically when encountering a situation that did not occur during training. And the classic ML sentiment echoed by multiple commenters: ideas are cheap, implementation matters. So where does that leave us? JEPA is a genuinely interesting approach to world models, and LeCun has the track record to take it seriously. He built convolutional networks, pioneered self-supervised learning, and now he is betting his entire career on predictive architectures. But the community critique is fair. JEPA promises world modeling from tons of unlabeled data without the quadratic shenanigans of contrastive methods. But we will soon know if it works at scale from all the labs trying their hand at it. The question is whether JEPA is the architectural solution to LLM's limitations, or if we are just looking for a magic bullet that does not exist yet in our toolbox. Only time and real implementation will tell. If you want to dive deeper into this topic, check out the Nebius Science article linked in the description. It gives a really detailed look at LeCun Lab and the AI world of 2030. Let me know what you think about JEPA in the comments. Do you think predictive architectures are the future, or are LLMs the real path forward? Thanks for watching, and I will see you in the next one.